Here's pre-calc. It's problem number, it's actually problem 7-127, but if you read 7-127, it refers you back to 7-126. So 7-127 says use your slopes from 7-126 to write the equation of a line that's tangent to each of the functions at the point where x equals 2 and to use point slope form. So in order to do that, we have to have done 7-126, which had all these four functions, a, b, c, and d, and it wanted us to use like our little formula for instantaneous rate of change. This finds the slope of the line tangent to the curve. That's what we've been learning about lately. So, and the way we do it is it's kind of just our slope formula. It's y2 minus y1, and then this is actually x2 minus x1, but the these two terms, they cancel out and they just leave you an h, like, because you'll have x plus h minus x, and so the two x's cancel out. And then we take the limit of that as h approaches 0, and that gives us the slope of the line tangent to the curve, because we were studying about that. So I don't want to make it too long about this previous problem, but basically you're plugging these functions in where x equals 2 in here, doing all the math, taking a limit, which in some cases you boil it down, you take a limit by just plugging in 0 for h, and this thing right here, that's the slope of the line that's tangent to this parabola here. Okay, sometimes you use the formula, like, you know, f of x plus h minus f of x all over h. And no h's, it's too hard to cancel the h's out. So you can just plug in 0.001 in these cases, and you get the slope of the line that's tangent to this exponential at x equals 2. The same thing with your logarithm curve. It's a curve, you know, it's a logarithm, and it's at x equals 2. We're looking at the slope of the line tangent to the curve, or how fast it's changing at x equals 2. And again, on this one, I had to just plug in the 0.001. We're getting these slopes. All these ones here on the right-hand side are slopes. I had to do the same little trick with cosine. So this is just from problem 7-126, but I'm going to use these curves and these slopes to write the equation of the line that's tangent to the curve. You know, like y equals mx plus b, but instead of y equals mx plus b, they want us to use, which is actually a little easier in this case, this is another equation of a line. Y minus y1 equals m times x minus x1. This is just another form for an equation of a line. But notice that in the previous problem, we just found m, right? There's my function, and the slope was, we found out it was 8. So I've written all my slopes and my functions down on this paper. And so what I need to do is get a y1 and an x1, and then m. I only need 3 things. I need a y, an x, and an m. But I already have the m because I did it in problem 126. So the x is going to be 2, because that's where we're trying to plug in. That's where we're looking for that's the point that we're trying to touch on the curve. So to get the y, I just plug 2 in. So 2 squared is 4 times 2 is 8. So here's where I show that I plug it in. And then I just replace y1 with the 8 and x1 with the 2. I'm just using this formula for point slope form. So I just keep doing it. So I already have my m, which I got from the previous problem, And then I'm just gonna plug 2 in so I can find a y, because I need like a ordered pair. So you plug 2 in here. 3 squared is 9. And then I can just plug my 2 in for the x2 and plug my 9 in. And so here's pretty much all of them. This one I had to use my calculator for. I plugged in 2. I found log of 2. Plug the y in for y. Plug 2 in for x. Use the slope from the previous problem. Those are my slope from the previous problem. Plugged my 2 in. Didn't have the y, so I had to plug 2 into the function to get the y. So that's all they're asking. Those are those are equations of lines tangent to the curve.